Hello and welcome to another one of Dee's ADD videos. Today we're going to look at coefficient of correlation. We're going to do an example. Real quick, the steps: you're going to need to be able to calculate your covariance, whether we're talking about the sample or the population. And then after that, find the variance. After that, square root the variance to get the individual standard deviation. And then plug into these formulas right here, depending on whether you have sample or population. So we're looking at this data set that we use to find covariance. If you watch a covariance video, on a scatter plot, you can expect an R value close to 1. It's pretty solid trend right there that's going up and to the right. As one goes up, the other one goes up. So what did we need to do? We needed to find the covariance. If you remember, we did that already. If we were looking at the two different ones, we came up with these two numbers here, right? But now what we need to do is, what are the steps? We need to find the covariance and the, all over the place. There we are, steps. Variance. So what you need to do to your table where you had the x, well, let's use a different color. Where you had the x minus x bar column, you need to, right next to it, write x minus x bar squared. And when you sum those up from 1 to 7, you get, let's see what I get. What did that? 47.71. Not sure where that came from there. And if we're doing x squared for the sample, since there's 7, we would take that divided by n minus 1, which is 6. And for the variance of the population, or actually no, this is the sample, sorry, you get 7.95. If you do the same calculation, and it's for the entire population, you just have n in the denominator, which is 7, which gives you 6.81. Alright? And then when you square root those to get your S or your sigma, you get, let's see, what did I get when I do that one? Square root of 7.95 was 2.82. That's your standard deviation of your sample right there. And your population one was 2.61. Doing the same thing for the y's. That would be the summation from 1 to 7 of the deviations in the y. That would give you, let's see, what was that value? 291.28. And then, depending on which one you're doing, if you're doing the sample, we do 291.28 divided by 6, and that would be the variance of your sample, which would be, let's see, for y it was 48.5, and for the population that was 41.57. 8. get those into our standard deviations, again, use square root. So here we're going to be doing square root of 48.5, which was the sample was going to be 6.96, and the other one for the population was 6.45. Alright, so now we have all the pieces of the puzzle to calculate either rho, which was the covariance over the individuals, or R, depending on which one you want to do. So the covariance for the population was down here somewhere, and that was 16.48. And then if you take the product of the sigma x, 2.61 times sigma y is 6.45. You're going to get a total of 16.48 divided by 16.83, which gives you a very close to 1 value of 0.977, as we expected. So that would be rho for the population, coefficient of correlation. And then for the sample, we would have, looking down there at the bottom, the covariance for the sample is 19.23 divided by 2.82, the standard deviation for the x, times 6.96, which is the standard deviation for the sample of the y. When you do so, you get 19.23 over 19.62, which gives you 9.799, I believe it was, which rounded to 0.980. Again, very close to 1, as we expected. Alright, so that's basically it. What did we do? We found the covariance. Luckily, we did that on the previous problem. Let's zoom out so we found the two covariances. Usually you'll be asked to find one or the other, and then you did find the individual variances. So what I told you guys to do is add these two columns, or add this column, and then you'll do the same thing for the y's. It'll be the deviation of y column, which you'd already calculated to find covariance, and then you would square that column, so that would be your new column, and this one here would be your new column. And then you sum them and divide by n or n minus 1, depending if you want the sample variance or the population sample variance or population variance. And then you square root them to get your standard deviations. And then after that, you plug into the main formula and you just put in your calculator. Alright, so that's an example of how to do the coefficient of correlation. So make sure you practice, practice, practice. And thank you, and have a nice day.